Okay, cool. So 10.3, we're going to do the derivatives of products and quotients. So we're going to learn two rules today, product rule and quotient rule for derivatives. So the first one up is the product rule. So if f and g are both differentiable, then the derivative of f of x times g of x is given as the formula f prime of x times g of x plus g prime of x times f of x, or to keep it really simple, f prime g plus g prime f. And this works for all derivative notations, y prime, dy over dx, d over dx. So I will show you how to use the product rule. Okay, so what we're going to do to label f and g, since we have two functions here, the first function is going to be f, and the second function is going to be g. Okay, and I'll write it out here. F is going to be 2x squared, and g is going to be 3x to the fourth minus 2. And now what we're going to do is we're going to take the derivative of f and g. So the derivative f prime, the derivative of 2x squared, is 4x. And then g prime, the derivative of g, is going to be 12x cubed. Okay. So once we have taken the derivative, all we have to do now is follow the product rule. So we are taking the derivative of f of x. So I'm going to start off with the notation f prime of x. And all I have to do now is follow the product rule, which is going to be f prime times g. So 4x times 3x to the fourth minus 2 plus g prime times f. 12x cubed times 2x squared. And now the calculus is done, the formulas is done, so all we have to do is simplify algebraically. So the rest from here is algebra. So we're going to distribute that 4x, and I'll get 12x to the fifth minus 8x plus 24x to the fifth. Combine like terms, and we will get 36x to the fifth minus 8x. And there's our derivative by using the product rule. So, any questions on that? Label what f and g are, take the derivatives of f and g, and then follow the product rule. Nothing else to it. Okay, let's keep going then. B, same concept. So we're going to use product rule again. So here's going to be f. So I'll just label it again. F is going to be 3x cubed. And g is going to be 2x squared minus 3x plus 1. Okay. Now, again, take the derivative of f, take the derivative of g. And then g prime, 4x minus 3. And once again, once you take the derivative, just follow the formula for the product rule. All right. So we're taking the derivative of y. So the notation I'll start with is I'll just say y prime and follow the formula. F prime g, 9x squared times 2x squared minus 3x plus 1 plus g prime f, 4x minus 3 times 3x cubed. Once again, The calculus is done. The product rule is done. The rest from here is strictly algebraic. Okay. So now distribute that 9. So I'll get 18x to the 4th minus 27x cubed plus 9x squared plus distribute that 3x cubed with the 4x and the negative 3. That'll give me 12x to the 4th and minus 9x cubed. Okay, and just combine like terms. So I have 18x to the 4th and 12x to the 4th, 30x to the 4th. And then I have negative 27x cubed, negative 9x cubed. That's negative 36x cubed. And all that's left over is that 9x squared. There we go. Did it again. Product rule. All right. Any questions on that one? All right. Next page, do it again. Let me come down. There we go. So there's F. F is 3x plus 2. There's G. 4x minus 5. Take the derivative of F. Take the derivative of G. And the derivative is done. Follow product rule. We're taking the derivative of G of X. So I'll start with G prime of X. And again, follow the product rule. F prime times G, 3 times 4x minus 5, plus G prime times F, 4 times 3x plus 2. Okay. Calculus is done. Product rule is done. Algebra on from here. 12x minus 15 plus 12x plus 8. So distribute the 3, distribute the 4, 12x, 15, 12x, and 8. And then combine like terms, 24x. And negative 15 plus 8 gives me minus 7. All right, and there it is again. Product rule. All right. All good? Okay. All right. D, same thing. Here's going to be F, which is going to be x squared plus 2. Here's going to be G, which is x squared minus 3. Derivative of F is 2x. Derivative of G is 2x. Taking the derivative of h of x, so I'll start off with h prime of x and just follow product rule. F prime G, 2x times x squared minus 3 plus g prime times f, 2x times x squared plus 2. Okay, again, calculus is done, product rule is done, algebra from here. Distribute that 2x cubed minus 6x plus 2x cubed plus 4x. Combine like terms, and we get 4x cubed, negative 6x, and 4x minus 2x. Okay, cool. And that was product rule, y'all. Nothing to it. Label what f and g are, take their derivatives, follow the product rule, and simplify algebraically. Any questions on the product rule? All right. Oh, I thought it was over. Never mind. Get two more, and then we get quotient rule. Okay, cool. So next ones. All right. X squared times e to the x. So just like all the others, there we go. There's f. F is x squared. And then there's g. G is e to the x. Take their derivatives. F prime is 2x. And then g prime is still e to the x. Okay. Taking the derivative of f of x. So f prime of x is equal to f prime g, 2x times e to the x, plus g prime f, e to the x times x squared. Okay. Not much you can do from here. I'm just going to rewrite it as 2x times e to the x plus x squared e to the x. I just put the x squared in front. You don't have to. It just looks better. There we go. All right. Last one. This is the last one for product rule. All right. So here's going to be f. F is x to the fourth. And then g is going to be the natural log of x. Take their derivatives, 4x cubed, and then g prime is 1 over x. We are taking the derivative of f of x again. So f prime of x, and we get f prime g, 4x cubed times the natural log of x, plus g prime f, 1 over x, times x to the fourth. So all we have to do is clean up these two. That's it. So this is going to become 4x cubed natural log x plus x cubed. The reason it's x cubed is because you can rewrite this as x to the fourth over x, which will give you x cubed. Now that finishes product rule. Everybody good with that?
Yep.
All right. Now we move on to quotient rule. If f and g are differentiable, then the derivative of f of x over g of x is the formula f prime of x times g of x minus g prime of x times f of x all over the original denominator g of x squared. Or keep it simple, f prime g minus g prime f all over g squared. So we're going to do the same thing with labeling again, but this time you'll label the numerator f and the denominator g. We'll take their derivatives and we will follow the quotient rule formula above. So that's what we're going to do here. Okay, so the derivative, so the numerator is f and the denominator is g. And I'll write those out here. So f is x squared, g is 2x minus 1. Take their derivatives again. F prime is 2x. G prime is 2. Now we're going to follow this quotient rule formula above. Okay, so we'll walk through this. So we're taking the derivative of f of x. So we'll first start with f prime of x. And now we do f prime g, 2x times 2x minus 1 minus g prime f, 2 times x squared. I just put that in parentheses to be proper. So it's f prime g minus g prime f, but this time you're going to put it all over the original denominator, but squared. So all over g squared. Okay, and now all we have to do is clean up the numerator. Calculus is done, derivatives done, quotient rule is done. Now we just simplify algebraically. All right. So that numerator, you distribute that 2x. So 4x squared minus 2x squared over 2x minus 1 squared. Combine like terms. And we get 2x squared minus 2x all over 2x minus 1 squared. And there it is. That is the derivative of a rational function using quotient rule.
Do we have to simplify the denominator?
Nope, there's no need to distribute that unless my math lab tells you to. If you're distributing it, you're just doing extra work. Good question, though. You leave it just as that. I mean, you could, if you wanted, you could factor the numerator more if you wanted to. You could take a 2x out and be left with 2x times x minus 1 over 2x minus 1 squared. So it'll take either answer. All right. Let's do it again. So numerator's f, denominator's g, and f is t squared minus t, and g is t cubed plus 1. Take their derivatives. F prime is 2t minus 1. G prime is 3t squared. We're taking the derivative of y, so I'll start with y prime and just follow your quotient rule formula. F prime g, 2t minus 1 times 2 cubed t cubed plus 1 minus g prime f. 3t squared times 2t squared minus t. I hate using t's. All right. And you put it all over the original denominator squared. Okay. And now we just have to clean up the numerator. So we have to FOIL the first two sets of parentheses here. So I'll get 2t to the 4th plus 2t minus t cubed minus 1, and then distribute that negative 3t squared over here, and you'll get negative 3t to the 4th plus 3t cubed. Just watch your signs and watch your distributing. And now our 2t to the 4th, negative 3t to the 4th gives me negative t to the 4th. And then what's the next highest power? Cubed, negative t cubed and 3t cubed will give me 2t cubed. And then all that's left is this t and that 1. So plus 2t minus 1 over t cubed plus 1 squared. Nothing else we can do there. All good?
Good.
Okay. We're doing it. We're moving. Okay. C, d over dx of x squared minus 3 over x squared. So do the same. Numerator's f, denominator's g. F is x squared minus 3, and g is x squared. Derivative of f is 2x. Derivative of g is also 2x. Now the notation is going to be a little different because it says d over dx. There's no function, there's no y equals, there's no f of x. So we have to start it out with the way it's written. So we have to say d over dx of x squared minus 3 over x squared is equal to, and now we can do the quotient rule. So f prime g, 2x times x squared minus g prime f, 2x times x squared minus 3, all over the original denominator squared. Okay. So again, derivatives done, quotient rule's done. Now we just clean up algebraically. So this would be 2x cubed minus 2x cubed plus 6x all over x to the 4th. And then we see that my x cubes will cancel. So what we are left with is 6x over x to the 4th, where the x's will cancel. This x is gone. Just put a line through it. And that 4 becomes a 3. So this will be our final answer of 6x cubed. All right. Let's keep going. Let's keep going. Let's put a dot here. So numerator's f. F is x squared plus 1. G is 2x minus 3. Derivative of f is 2x. Derivative of g is just 2. There we go. Derivative's done. We're taking the derivative of f of x. So we'll have f prime of x equal to f prime g, 2x times 2x minus 3 minus g prime f, 2 times x squared plus 1, all over 2x minus 3 squared. Okay. Derivative's done. Quotient rule's done. Now we just clean up algebraically. Distribute that 2x, 4x squared minus 6x. Distribute that negative 2, negative 2x squared minus 2, all over 2x minus 3 squared. Clean up one more time. My x squared, 4x squared, negative 2x squared, that gives me 2x squared. There's only a 6x by itself, so minus 6x, and that 2 is all by itself, over 2x minus 3 squared. And again, that should be a good answer, but if it did ask you to simplify more, you could take a 2 out and be left with x squared minus 3x minus 1 over 2x minus 3 squared. And there we go. All right. Any questions on those two? All right. And I think these are the last two. Perfect. See, a lot of time left over. So, okay. So, E. Do it again. Numerator is F. Denominator is G. So, F is 1 minus e to the x. G is 1 plus e to the x. Derivatives. F prime is just going to be negative e to the x. And g prime is e to the x. All right, so there's our derivatives. Now we follow the quotient rule. We're taking the derivative of f of x. So notation is f prime of x. And here we go. F prime g, negative e to the x times 1 plus e to the x minus g prime e to the x times f, 1 minus e to the x. all over 1 plus e to the x squared. Oh, look at all those letters. So derivative's done, quotient rule's done. Now let's clean up algebraically. So we have to distribute those e to the x's. So before I do that, just a side note. When you have e to the x times e to the x, since these are the same base, I'll come over here. Since they are the same base, you add the exponents. So e to the x times e to the x will become e to the 2x. This shares the same properties as if I said x to the m times x to the n. Since they are the same base, this would become x to the m plus n. So you add the exponents when you have the same base. Okay, so now back to this. We distribute negative e to the x minus e to the 2x minus e to the x plus e to the 2x all over 1 plus e to the x squared. Clean up, and we see that my e to the 2x's cancel. And my negative e to the x minus e to the x becomes negative 2e to the x over 1 plus e to the x squared. And there's nothing else we can do there. Now, any questions on that one? Maybe calculus is too easy now, right?
Yes, sir.
All right. Cool. Well, last one then. So F and G. Bring this down a bit. There we go. So F will be 2x and G will be 1 plus the natural log of x. And then F prime is 2. G prime is 1 over x. All right, derivative's done. We are taking the derivative of f of x. So notation is f prime of x. And follow your quotient rule. F prime g. 2 times 1 plus the natural log of x minus g prime f 1 over x times 2x. And we put this all over 1 plus the natural log of x squared. Okay. Now all we have to do is clean up, and we'll get 2 plus 2 natural log x minus 1 over x times 2x is just 2 over 1 plus the natural log of x squared. Parentheses, sure. Okay, and again, just to show you why, you can rewrite this as 2x over x which gives you the 2. All right, and our 2's cancel. And we are left with our final answer of 2 natural log x over 1 plus the natural log of x squared. And I think that's it. So that was product and quotient rule. Any questions on that lesson?
Easy.
All right. Good to know.